what normally happens to indicate bits is we can do on, off. We use on, off to represent bits in optical signaling. So when you're using fiber, it's on or off. So I can go off, on, off, on, off, on. Okay? I'm going to be sending something out a light source here. So I'm shining a light here. This is me on my flashlight, right? Flashing my flashlight off and on, and each one of these becomes a bit. So off is 0, on is 1, on, off, on, off, on. Okay? Easy stuff. Over here I need a sensor, something that can detect when the light was on or off. I think they're doing stuff to turn the thing into electricity, but I don't remember exactly how this works. We don't need to know, because we're MIS people. We're not electrical engineers. And I'm not even going to go there, because I do know actually how they make the laser go. But we'll worry about that one. We have other stuff that's just as crazy to worry about. All right, so that's optical. If we're doing copper, so if we're sending something over electrical, we use positive or negative voltage. So I might have a 12 here and a minus 12. I'll put a little v. So I got 12 volts and minus 12 volts. If I want to do a 0, I'm going to send, what am I sending for 0? 12 volts. If I want to send a 1, I send minus 12 volts. So there's the same message on my copper cable. So there's a 0, a 1, a 1, a 0, a 1, a 0, and a 1. Okay? Now, here we do, well, that's okay. Now, let's say our electrical sensor is over here. Over here, we sense, we use a voltmeter to see, is it positive or a negative voltage? We already talked about attenuation, right? So over distance, we have these high voltages. What happens to our voltages? They gradually get weaker and weaker, but once we get down here, and this isn't too far away, I'll just draw a, so this is a little weaker. I can still tell one is negative and one is positive. Okay. Okay, so I can tell negative or positive. And that's how we tell a 1 from a 0. That's really cool. Okay? This kind of signaling, by the way, if there is one, what am I doing here? One bit per cycle. That means there are 2 states, okay? So do you guys see how there's 2, what we would call states of the medium? My signal can be a positive voltage or a negative voltage. That's 2 states, and I can send 1 bit per cycle. The light's the same way. It can be off or it can be on. So there's 2 different things the light can do, off or on. Therefore, I can send 1 bit at a time. This, just so you know, is resistant to attenuation errors, especially, or with copper, using 1 bit, this is called binary. A binary signal, which has 1 bit per cycle, is resistant to attenuation errors. You know I'm going to show you a different type. If I want to send more than 1 bit per cycle, I need to have more states. So I'm going to draw my 12 and my minus 12 again. And now I'm going to have 4 different possible voltages. I'll have a 12, I'll have a 6, I'll have a -6, and I'll have a -12. And now I wrote those too small for my big old fat pen, sorry. So the 12, I can have a 0 and a 0. I can have a 0 and a 1. I can have a 1 and a 0. And I can have a 1 and a 1. Okay? So with 4 different places, 4 different states of my signal, I can now do 2 bits per clock cycle. Okay? So with 4 states, I get 2 bits per clock cycle. But now think about when I get out here. Now my receiver is having to tell the difference between, 1.5 and 0.75 and 0.75 and, or minus 0.75 and minus 0.15. What did I say? I don't remember. But anyway, it's harder to tell. So attenuation here is more of an issue. Okay? We good with that? So here it was just negative from positive. That's easy to tell. But when I'm trying to tell the difference between 2 positive voltages that are really close to each other, then I've got problems. Okay? So attenuation is more of an issue. And the bottom line is, it's the same as we were saying. If you go too far and you can't tell, the solution is back up a little bit. So we're going to back up and not go as far. Okay, so that's a binary signal. That's really fun.